Now remember, when we're talking about the ambiguous case for the law of sines, we have several different outcomes that could happen. So in this particular example, we're going to look at what could happen if I'm solving and I end up with two triangles. So here we are given that we know we have a triangle. We have angle A given at 61.4. I know side A and side B. So I want to find, again, all of the angles and all of the sides to be able to fill in the triangle. First, we're going to apply the law of sines to the known ratios that we are given. In other words, I know the ratio of the A's, so I have side A over sine A would be equal to side B over sine B. And when I fill in this information, A would be equal to 35.5 divided by the sine of 61.4 equals side B, which is 39.2 divided by the sine of B. So it's sine B that I'm solving for. So sine B is equal to 39.2 times the sine of 61.4 divided by 35.5. When you simplify this part right here, we end up with the sine of B equal to 0.9695. But again, we have two possible angles or outcomes when I take the inverse sine, because sine is positive in both first and second quadrants, so I have two possible angle measurements that could work here. So let's go ahead and we're going to take the inverse sine, and when we do that, the first angle, we'll call it B1, is going to be 76, and that would be the angle that's falling in the first quadrant. Now we'll say that angle 2, or not angle 2, but B2 is going to be this angle that I would get if I fell in the second quadrant, which is 180 minus 76, or in other words, 104. Now just to check, to be consistent, do both of these angles work? Do I need to throw an angle out? I don't know yet. So let's see what we've already got. I know that the measure of angle A is 61.4. So 76 plus 61.4 is equal to 137.5. So with angle B added to angle A, I'm less than 180, so I have some wiggle room for my last angle C of this triangle. Does that hold true over here for 104? So let's add our angle A to that, 61.4. And when we do, we end up with 165.4. So in other words, I'm still less than 180, and I've still got some room for angle C. So both of these angles work for possible, for my triangle. So we need to account for that information when we're solving. So let's see. I have some pictures down here that might help show what it is that we're looking at. So I filled in these triangles down here to show you what we have right now. And this large triangle on the left-hand side has both of the triangles that we're solving for. This is the case where we have the two triangle case. In other words, we have a large triangle with a smaller triangle inside. Now these remaining two pictures are just this first figure separated into the two separate triangles. And all I did was fill in, and let me finish, I didn't fill this one in, 35.5. All I did was fill in the information that we know so far. We were given that side A was 35.5. Now when you have side A on a triangle that's this case, that side A is across from angle A in the large triangle, but it's also this kind of interior side here, which is again across from angle A. So that's what we were given. I know angle B, or excuse me, side B was given as well. This is the 39.2, which falls across from both. So it would be across from both angle B's. We were given in the original part that angle A is 61.4. Now we just solved the fact that I have angle B1, which was the smaller angle here of 76 degrees, and I had this other angle in here which is 104 degrees. So what am I left to find? Well, first of all, I need to know what side C1 is going to get me, and I also need to find what angles I'm going to get as well. So the easiest way to figure out these missing pieces is to go to the individual triangles, because it can get a little confusing if you're looking at it over here. So we're looking at, we need to know angle C1 as well as side C1, and we can use any of these known ratios in order to find that. So let's just start, and we'll say, okay, I need to know angle C1. I find that by taking, so C1 would be equal to 180 minus 76 minus 61.4. And I find out that that would be equal to 42.6. So I know C1 is 42.6. Now I can use the law of sines to solve for side C1. So C1 would be over the sine of angle C1, which is 42.6. That's equal to, let's just choose side A, which is 35.5, not 2, 35.5, divided by the sine of 61.4. So we're solving for C1. When we cross multiply here, 35.5 times the sine 42.6 divided by the sine of 61.4, we find out that side C1 would be equal to, let's say, about 27.3. Okay, so that's how we used angle C1 and side C1 to find out the rest of our triangle. We can do that again over here for our smaller triangle in exactly the same fashion. So we want to know, well, what is angle C2? So we take 180, subtract angle A and angle B2, so this is A minus B2, and we find out that that value should be 14.6. And then we're going to do the same setup we had over here. So when I want to know side C2, I'm going to divide that by the sine of C2, which is 14.6, and we'll just use this same ratio for A's, 35.5 divided by the sine of 61.4, and we find out that C2, I keep writing C1, we find out C2 is equal to 10.2. So that gives us all of the sides, but you can see that it might be easier to break our single triangle or our single diagram here, single figure here, into two separate figures, and it might be just a little easier to see how we can apply this ambiguous case of the law of sines.